Okay, part 2. Somebody read.
Cube has a volume of 3 times 10 to the -3. When the external pressure is 1 atmosphere, the bulk modulus of the material is 4 times 10 to the 12 Newton meters squared. Question A: what is the change in volume when the body is subjected to a pressure of 6 atmospheres? And question B: what additional energy per unit volume is now stored in the material?
So what do you think we should do? What is the change in volume? What are we looking for? Delta V, right? So what formula should we use? Oh, and then also it says it has the original volume of 3 times 10 to the -3. Oh, external pressure, P0 is 1 atm. What is the change in volume when it is subjected to a pressure? So what's the P2? 6 atm. What is the delta P change? 5 atm. We should probably convert it to Pascals. How do we convert this to Pascal? Good. Okay, and they give us bulk modulus. So what formula should we use? The bulk modulus one, which was B
Measure delta P over delta V over V naught.
over V naught. Do we have everything? Do we have V? Do we have delta P? Do we have V naught? We just plug and chug, right? Now, what's the part B? Additional energy per unit volume. So this is interesting. This is something I want to talk about. So we're good with this, right? We can plug them in. Good. What is the energy per unit volume that is stored in the material? So the way you would do that is you will take this equation, write this as, we talked about this, right? PdV, work is PdV. We also know work equals energy. Do we also know that? If it's plus, it's kinetic. If it's minus, it's potential, right? Work kinetic energy theorem or work potential energy theorem, plus and minuses. Okay, so remember that. What is it asking? Energy per unit volume. So we have to just find work and then divide it by volume to give us energy per volume. Work is PdV. May I write this equation, V equals minus dP over dV over V naught? For small change, can I do that? May I also then rewrite this as dV equals minus V0 over V dP? I'm just rearranging things. May I multiply both sides with P? And why am I doing that? Because I want to come up with this expression. Yeah? May I multiply both sides with P? Can I do that? May I also integrate? So what will this side become?
Negative work.
Negative work? What will this side become? Is V0 a constant and is B a constant? Will I get P dP on this side? What's the integration? Well, minuses go away. V0 over B, P squared over 2 from what to what? Which was P, P2 to P1, right? It was subjected. I just want to make sure I don't mess it up. So P0, it was 1 atm, right? So it was this. Okay, so then that means I could just write V0 over B, P2 squared minus P0 squared equals work. Okay, can I move this V0 on this side? Yes? And then it's just plug and chug. Do we have B? Do we have P2? Do we have P0? right? P0 was 1 ATM. P2 was 6 ATM. Plug those values. Oh, convert them to pascals and then plug them in. Woohoo.